So hello everyone and welcome to this class on I'm Aditya Mishra and welcome to this class on aeronautical engineering, or those who are interested in pursuing higher studies in aerospace or aeronautical engineering or flying vehicles. Generally, when we talk about of an aeroplane has in air can perform 6 different types of a motion. These 6 different types of motion, they are also known as degrees of freedom. So if an object can perform 3 types of a motion, that means it has 3 degrees of freedom, right? So here 6 different types of a motion when we say, or 6 degrees of freedom when we say, generally these 6 degrees of freedom plus 1 or 2 is also performed when in a fighter jet or a fighter plane. Okay, but here in normal aeroplane, when we talk about a commercial aeroplane which we are boarding here to go to some destination, they will generally have 3 degrees of perform motion, and they can perform only 3 different types of motion. Okay, so what are these 3 different types of motion, and how these motions take place when we talk about an aeroplane, in an aeroplane, so that we are going to study. So first of all, as you can see in this picture, there are 3 axes. One is longitudinal axis. You can also consider a horizontal x-axis, which is passing through the fuselage of an aeroplane, right? Then there is y-axis, or a vertical axis, which is perpendicular to this x-axis. A third axis which you can see parallel to the wing of an aeroplane, that is also called as a lateral axis. So longitudinal axis, we can consider it as x-axis, vertical axis is y-axis, and lateral axis is basically the z coordinate or z-axis, right? So about these 3 axes, an aeroplane can perform 3 different types of a motion. The first motion, which is it can perform about lateral axis, or the axis which is passing through the wing, which is also, you can see, it is known as a pitching. An aeroplane can do pitch up or pitch down or pitching. Second is longitudinal axis, or about the horizontal axis. An aeroplane can actually perform rolling motion. It can roll like a ball if we are talking about in air, right? And the third kind of a motion an aeroplane can perform, it is known as yawing. So there are 3 types of motion and 3 axes: longitudinal x-axis, which is x-axis, vertical axis which is y-axis, and lateral axis which is z-axis. And the motions that it can perform: about x-axis it can do rolling, about y-axis it can do yawing, and about the horizontal or lateral axis actually it can perform pitching. So how these 3 motions takes place when we talk about 3 degrees of motion of an aeroplane? So here you can see the motions of an aeroplane. When we talk about rolling of an aeroplane, the rolling is done about which axis? Rolling is done about longitudinal axis. So in order to make an aeroplane roll, the control surface, okay, the surfaces which are present there in aeroplane to help the aeroplane perform these actions are called control surfaces. For rolling of an aeroplane, the control surface which is present is known as an aileron. At the rear end of a wing, you can see in the corner there will be a small portion which can go up and which can go down, which can be deflected up and down. So the opposite deflection of these ailerons actually make an aeroplane roll or perform rolling action about the axis which is passing through the fuselage, which we called is an x-axis. Then coming to the second motion of an aircraft, which is also known as yawing. Like we can take left and right. When we are walking on a road, we can turn to the left, we can turn to the right. In the similar manner, an aeroplane can also take left and right turns. It can simply bend to the left, bend to the right, with the help of a controlled surface which is called rudder. Rudder is present at the tail portion, at the rear end. As you can see here, this upper portion, this is known as a rudder. Okay, when you make this rudder turn to the left, the aeroplane will go to the right, opposite. Okay, so if the rudder goes to the left, aeroplane moves to the right. If the rudder goes to the right, aeroplane moves to the left. So this left and right motion of an aeroplane, which is happening about the vertical axis, the perpendicular axis, as we have seen, y-axis, this is known as yaw. So yawing motion is actually done with that particular axis, as you can see from here also. So yawing motion is about vertical axis. An aeroplane can take left, an aeroplane can turn right. Then coming to the third motion, which is also known as pitching. an aeroplane can move up and down about the lateral axis, an axis which is passing through the fuselage, which we call as z axis. So these are three common motions which an aeroplane takes place, or which you can observe when we are flying through a commercial aeroplane. And the control surfaces are basically responsible for making an aeroplane move, or take a turn to the left or right, or roll, or it is actually yaw. So when we talk about an aeroplane, there are many things that we should be actually talking about: the control surfaces, and there are many other surfaces which helps the pilot without even touching the portion. It can make the aeroplane bend, it can make the aeroplane tilt. So these are some of the control surfaces which are very handy when a pilot is actually trying to make an aeroplane move. So here we have an aileron, and like we have seen, the aileron is actually responsible for making the aerofoil, making the aeroplane roll about the longitudinal axis, about the axis which we have seen here. This is longitudinal axis. About the longitudinal axis, an aeroplane can roll, like we can see here, and for this the control surface which is responsible is actually aileron. Here we have in the corner of the wing at the rear side. Then we also have a second control surface which is actually rudder. Rudder is responsible for yawing motion of an aircraft. If the rudder goes left and right, an aeroplane can tilt to the left and right, which you can see here, tilting the left and right. This motion, yawing motion, actually it is happening about the vertical axis, as you can see from here. An aeroplane can go left, an aeroplane can go towards the right. So this is the second control surface, which is very, very important, without which a pilot cannot make an aeroplane tilt, right? In olden days we used to use you can say rubber or strings, but nowadays everything is controlled by hydraulic or pneumatic devices, pressure based and liquid based devices. So we have this second surface, rudder, which is also present here. Then the third one here you can see is actually, we have aileron, we do have rudder, and then there are some other mechanism surfaces which are present here, which is called flap. Flaps are responsible for increasing the lift as they go down. Many times you will see when an aeroplane is taking off, a larger surface, a bigger surface at the back of the wing, actually it goes in the backward direction, and it allows. Then we have third surface, which is known as an elevator. This elevator is responsible for the pitching of an aircraft, as you can see here. The pitching of an aircraft takes place, or aeroplane takes place, when it is going, the nose of the aeroplane is going up and nose of the aeroplane is going down. When the aeroplane is actually taking off, it has to pitch up. So this elevator or the control surface is actually bent in the upward direction, in the downward direction, so that an aeroplane can go up opposite. Like we have seen here also, it is opposite. When the rudder is tilted to the left, the aeroplane goes to the right. Actually, sorry, the rudder is tilted in the same direction. If the rudder is tilted to the left, the aeroplane goes to the left. If the rudder is tilted to the right, the aeroplane goes to the right. So the control surfaces plays a very, very important role when we are talking about motion of an aeroplane. Then we also have, there is something called horizontal stabilizer, elevator, rudder, ground spoiler, aileron, slats. Slats are also responsible for improving the lift, which we will see in the coming classes. Okay, and then I hope you understood what is degrees of freedom of an aircraft, and a normal aeroplane actually has how many degrees of freedom. So thank you very much. Have a very